Yes, very good afternoon to all my dear students. I am Ms.P.A.Puranik, Faculty of Computer Engineering Department, West Modern College of Engineering, Pune. So today we'll start with the next unit, that is a public key and management. So in this we are going to learn the Rsa algorithm, Deffie Hellman key algorithm, and elliptic curve and format theorems. So cryptography. So what is that exactly? What is the encryption? What is the decryption techniques? Converting the plain text to ciphertext, that is called as encryption. Converting the ciphertext to plain text called as a decryption. That is nothing but encoding and the decoding. So here public key or the two key asymmetric cryptography involves the use of two keys, that is a public key and the private key. A private key known only to the recipient used to decrypt the message and create the signature, whereas in public key we can verify the signature which may known by anybody and can use to encrypt the message. So here public key cryptography is asymmetric because those who encrypt the message or verify signature cannot decrypt the message or create the signature. So here in this diagram you can see, very first we'll start with the Rsa algorithm. So Ron Revist, Adi Shamir and Len Edelman have developed this algorithm. Revis Shamir Edelman, that is RSA, have developed this algorithm in 1978. It is a public key encryption algorithm. It is a block cipher which converts the plain text into the ciphertext at a sender side and vice versa at the receiver side. So here in this diagram you can see Bob having a public key who this sharing with the Joy, Malik, Alice and the Ted with the persons, but Alice is having public and the private key both. So this is a plain text using encryption algorithm RSA. It is converting into the ciphertext. So this transmitted ciphertext again received by Alice, and with the help of private key he can convert it back to the plain text. So as I have told, Revis Shamir and the Edelman who first publicly described this in 1977. So here there are the three main steps involved in the Rsa algorithm, that is a key generation, public key encryption and the decryption. So let's start the key generation first. What are the different steps for the key generation? So here first step is what? Select two prime numbers which are not same, which should be different, and calculate n is equal to p into q. Then calculate phi of n is equal to p minus 1 into q minus 1. Next step is what? Select integer e such that GCD of phi of n value, here we are calculating phi of n value which is equal to p minus 1 into q minus 1. So GCD of phi of n comma e is equal to 1, whereas 1 is less than e is less than phi of n. After this step you can calculate d. So d is e to the power of minus 1 mod phi of n, or we can write it as ed mod phi of n is equal to 1. So once we get the value of e and d, we can calculate public key and the private key. This is called as a key generation, generating the public key and generating the private key. So public key pu is equal to e comma n. Now we know the value of e and we know the value of n, and private key is equal to PR equal to d comma n. We know the value of d and n. So after key generation steps we can perform the encryption. So what is the formula for that? C is equal to p to the power of e mod n, whereas p is nothing but your message or plain text message. Then decryption, converting the plain cipher to the plain text, m is equal to c to the power of d mod n. So this algorithm will understand by with an example. So let's here first step is that select two prime numbers. So here I am selecting two prime numbers, p is equal to 13 and the q is equal to 11, e is equal to 13. This is a randomly selected number from integers. So compute n is equal to p into q, that is 13 into 11 is equal to 143. Now phi of n is equal to p minus 1 into q minus 1 is equal to 12 into 10, that is 13 minus 1 into 11 minus 1. So you get the value of 120. Now calculate GCD. You know the value of e is equal to 13 and n is equal to 143. sorry, phi of n is equal to 120. So E of n, that is a 7 comma 120, is equal to 1. So GCD of E comma E is equal to 1. Now calculate D. D is equal to 1 mod 160 or D is less than 120. So how we can write this D? D is equal to phi of n into 1 plus D is equal to phi of n into I plus 1 divided by E. In this way also we can write the D equation to find the D value. So let's put our I value. I value will be I is equal to 1 to 100 till you get integer number. So put I value till you get integer number. D is equal to phi of n into I plus 1 divided by E. So put the value of I, n and E. D is equal to phi of n value is a 120, I value is a 1 plus 1 by E value is a 13, that is equal to 9.30. But this is not a whole integer number. We need integer number, not a float number. So again put value I value is equal to 2. Phi of 120 plus 2 into 2 plus 1 divided by 13 is equal to 18.53. Similarly, phi of 120 into 3 plus 1 divided by 13 is equal to 27.76, which is also not an integer number. Then if we are taking I value is equal to 4, then phi of 120 into 4 plus 1 by 13 is equal to 37. So this is your D value. So private key is equal to D comma n, that is a 13 comma 37 comma 143, and public key is equal to E comma n, that is a 13 comma 143. So here we got the public key and private key. So first step is done, that is a key generation. Next step is to calculate the C Vertex. C is equal to P to the power of E mod n. So 13 to the power of 13 mod n is mod 143 is equal to 52. So this is your C value. Put this C value to calculate the plain text. P is equal to C to the power of D. So what is the value of C? Here we have calculated, that is the C value is a 52. So 52, and what is the value of D is equal to 37. 52 to the power of 37 mod 143 equal to 13. So you get the same plain text message. So here is plain text message 13 you got, that is n is equal to 13, and at the end also after converting this C Vertex to the plain text, same message you are getting. That means both sender and the receiver can communicate with each other in a future because it is matching. Okay. So this is example of Rsa algorithm. Next we'll see the Deffie-Hellman key and elliptic curve. So before understanding the Deffie-Hellman key, we'll understand what is elliptic curve. So elliptic curve is an approach to the public key cryptography based on algebraic structure of elliptic curves over the finite fields. So elliptic curve cryptography, that is ECC, requires a smaller keys as compared to non-ECC cryptography to provide the equivalent security. So for better understanding elliptic curve cryptography, it is very important how we can write y to the power of y square is equal to x cube plus ax plus b is standard. This is a basic equation, whereas a is a coefficient of x and b is the constant of equation. So the curve is non-singular, that is the graph has no cups of self intersections. In general, elliptic curve looks like an simple curve, and intersection points also we can find. So here you can see this general elliptic curve look like this. So here this green line, if you see, this is the intersection points we can find P, Q, R. This brown color line is, or red color line is a elliptic curve. We have drawn this curve over x and y axis, and formula is y square is equal to x cube plus ax plus b. So P is that the curve is defined over, G is the generator point, A comma B is the value of defined on the curve, H is a cofactor, and N is a prime order of is also P comma G. And private key selected by Alice is A, private key selected by Bob is B. Key generated is equal to x to the power of G, x is equal to G to the power of A mod P, and key generated by Bob is Y is equal to G to the power of B mod P. Now after this they will exchange the generated key take place. Key received by Alice is a y and key received by Bob is x. Now generated secret key Ka is equal to y to the power of A mod P, and generated secret key by Bob is Kb is equal to x to the power of B mod P. So algebraically it can be shown Ka is equal to Kb, and users now have symmetric key to encrypt because they are the same secret keys. Now here let's take one example. Alice and Bob gives the number of P is equal to 23 and G is equal to 9. Now Alex selects the private key A is equal to 4 and Bob selected the private key B is equal to 3. Now Alice and Bob, how they are communicating? X is equal to p to the power of A mod P, and that is equal to 9 to the power of 4 mod 23 is equal to 6, and Y is equal to p to the power of B mod P. You will get 16 value. Now Alice and Bob both will exchange this key. So Alice key is public key value 6 and Bob is a 16, but they will exchange with each other. Now Alice is a 16 and Bob is having 6. Now Alice and Bob communicating the symmetric key, that Y is equal to Y to the power of A mod P. So here Y value is 16 to the power of A value is equal to 4 mod P, 23 is equal to 9, and X to the power of B mod P, X value is a 6 to the power of 3 mod P value is a 23. You will get the 9 as answer. So both are same, so that 9 is a shared secret key and they can communicate with each other in the future, right? So yeah, this is how we can work with the help of these two algorithms, RSA and Deffie-Hellman key algorithm, to encrypt the data to secure our information. Thank you.